Right. Picture this, a brain that looks like it's been tie-dyed with shades of purple and green. And then there's this big metal contraption that looks like two Siamese magnet rings having an existential crisis on top of it. It's like the brain is trying to get some groovy stimulation, but the magnet is just giving it a weird magnetic side-eye. You've got some sliders for intensity and pulse frequency, making it seem like you're DJing the brain's electrical party, and a choice between coil types. Figure 8, which sounds like a contortionist, and circular, which is basically this classic what are you doing here design. Overall, it's a quirky little setup that makes brain stimulation look like a science experiment gone playfully wrong. To make the coil movement feel more grounded, you could add a simple fixture or articulated arm design to the visualization. It would give it a more realistic structure, like it's actually being positioned by something in the real world. For the simulation parameters, enhancing the visual feedback during stimulation could make it more intuitive. Maybe show a clearer representation of the magnetic field or its effect on the brain regions being stimulated. And to add some context, you could include a description text below the canvas that explains the basics of TMS, the function of different coil types, and how the intensity and frequency affect the simulation. That would make it more engaging and informative for users. All right, let's put in the critical hat. While the colorful brain is visually appealing, the overall simulation feels a bit basic, to be honest. The coil movement is just dragging, lacking the realism of a precise positioning system. And those sliders for stimulation parameters, they're functional, but the visual feedback for their impact on the brain is pretty lacking. It's like you're fiddling with controls without really seeing the clear effect on the tie-dyed brain. Plus, a bit more context or explanation within the interface would be super helpful, instead of just sliders and a start button. It needs a bit more polish and depth to feel truly effective and informative. Yeah, absolutely. Adding a distance from the brain to mimic the skull would be a great improvement. It would make the simulation much more realistic, as the TMS coil doesn't actually go inside the brain. Constraining the coil's movement to stay at a set distance above the surface would provide a more accurate representation of how the stimulation works and make the whole experience more scientifically valid. It's a key detail that would add a lot more credibility to the simulation. You're absolutely right to be critical about the default stimulation settings. If they're inaccurate, that's a major issue, especially since this kind of stimulation can have serious consequences if not controlled properly. To make the simulation more accurate and responsible, it should include realistic parameters that reflect typical TMS treatment settings, like intensity and frequency used in medical practice. There should also be clear warnings and limitations on the settings to prevent users from accidentally selecting values that could be harmful or unrealistic. Incorporating accurate safety protocols and realistic settings would make the simulation much more educational and reliable. Okay, diving in deeper into the fun critical side, that brain model, while colorful, looks a bit like a melted tie-dye mess. It's not exactly representative of actual brain anatomy, which could be pretty confusing for anyone wanting to understand precise targeting. And the coil placement? It's like playing a guessing game. There's no clear guidance on where to position it for specific effects, making the whole simulation feel more like a random toy than a useful tool. It would be significantly better with some proper anatomical mapping and indicators for targeted stimulation areas. Otherwise, it's just a colorful distraction without the real scientific value it could have. Looking at the changes, it seems the developer has added a distance constraint to the coil, so it no longer goes inside the brain. That's a good step for realism, but the interaction itself still feels clunky. You're just dragging the coil around, and there's no precise way to target specific brain regions. The text editor shows changes to the coil's positioning code, but there's no mention of improving the visual feedback or making the targeting more intuitive. It's like they fixed the basic movement issue, but haven't addressed the core problem of making the simulation genuinely interactive and informative. It's a half measure, and it still needs proper controls and clear guidance for effective use. Those lines are supposed to represent the magnetic field lines generated by the TMS coil. They're intended to show the shape and direction of the magnetic field that's supposed to be interacting with the brain. However, the visualization is pretty simplistic in wave, making it difficult to understand the actual impact on specific brain regions. It doesn't clearly show the field's strength or penetration depth in a way that's truly informative for understanding the stimulation. To make it better, the simulation could incorporate more accurate anatomical models, perhaps with clearly labeled brain regions. It should also provide precise visual feedback on the intensity and penetration depth of the magnetic field, maybe with heat maps or indicators showing which areas are being stimulated. Additionally, implementing a more controlled placement mechanism, perhaps with snapping points or guidance lines, would make it much more user-friendly and scientifically accurate for demonstrating targeted stimulation. Clear explanations of the parameters and their effects would also enhance the educational value, making it not just a visual demonstration, but a useful tool for learning about TMS. You're supposed to move the coil using your mouse, but as you pointed out, the control is pretty imprecise. You can click and drag the coil, but there's no clear guidance or snapping points to help you position it accurately on specific brain regions. It's more like a vague manipulation rather than precise targeting, which makes it difficult to understand the exact area being stimulated. All right, let's get even more critical and fun. The simulation feels incredibly limited, like a bare bones attempt at something potentially interesting. The brain model is still too generic, and the coil manipulation is like trying to perform brain surgery with a pair of oven mitts. There's no sense of precision or the actual impact of the stimulation, and the lack of detailed feedback on the magnetic field makes it feel more like a cartoon version of the process than a useful simulation. It's like a fancy digital toy that doesn't really teach you anything or provide any meaningful interaction. They focused on the bare minimum and missed the opportunity to create a truly engaging and informative experience.